So, in last class we were discussing about the crystal planes, how it is represented using Miller indices. So, we have represented crystal plane using Miller indices HKL so when HKL put in a first bracket, so it represents the crystal plane. So, as I mentioned that HKL which we represent for a plane, it's represent a basically a set of equidistant parallel plane so it's if I show say so it's a plane say passing through the origin, and then so these are the planes, they are parallel and they are equidistant. So this if this plane is represented by say which plane it will be? It will be basically, you can see if it is a axis, it is b axis and this is c axis. So this plane it cut at b axis but parallel to a and c axis. So it will be 0 1 0 plane. So HKL value is 0 1 0 and then this all parallel planes, equidistant parallel planes will be represented by this Miller indices 0 1 0. Now that distance, that equidistance basically you can, this is the distance. So this DHKL, so this they are equidistant, right. So that I have discussed how to find out the planar spacing of a plane, say HKL plane. So that we have seen the DHKL, that is equal to that is h by a whole square plus k by b whole square plus L by c whole square, and that is minus half. That is minus half. I think you cannot see this one here. So this is basically minus half. Okay. So this is the how we found this one. So one has to take normal on this plane from the origin, and then so any line if we draw from the origin, so that line have a direction cosine. So basically it makes angle with these three axes, and direction cosine is basically this cos of those angles, and that follows this some rules. Cos square, say I wrote phi a plus cos square phi b plus cos square phi c equal to 1. Okay. And cos phi a, cos phi b, cos phi c, that is basically that if normal is d h k l, so this d h k l will be that we have seen angle between this direction, normal direction, and the a axis. If it is phi a, so then we have seen, so this d h k l will be a by h cos phi a by h cos phi a, and that along the b axis, if angle is phi b, so b by h cos phi b, and this will be c by l. So not this is h, this will be k, c by l cos phi c. Okay. So from here one can get cos phi a, cos phi b, cos phi c in terms of DHKL and ABC and the Miller indices, and from this relation one can find out this. So now today we would like to find out what is the angle between two crystal planes. What is the angle between two crystal planes that we want to find out. So just let us consider two axis system. So this is A axis, this is B axis, and this is C axis. So angle between two crystal plane, angle between two crystal plane right. So say this is one plane, this is one plane. So, this is the origin O, and this plane say A, B, C plane. So, now if we draw a normal on this plane, the foot of the normal on this plane is say N, and say this is that ON is DHKL, right, and this length is, we have seen A by H, this is C by L, and this will be B by K. Now, if you draw another plane, say if we draw another plane, but it is not straight line, it seems this is not straight line. I think still it is not that one. So, it is now better one. Okay. So, this is the another plane. So, we would like to find out what is the angle between these two planes. So, you know that angle between these two planes will be same as the angle between the normal of these two planes. So, this is one normal of this plane, this is N. So, another normal on this plane, other plane. So, this is say A dash, B dash, C dash plane. So, normal that foot is N dash. So, it is that planar spacing is say D H K L dash, okay. And then we can similarly for this plane A dash B dash C dash plane. So, you can write A by H dash cos phi A dash. So, if direction cosine of this normal O n dash, if this is cos phi A dash, phi B dash, phi C dash, and this E by H dash. So, basically this Miller indices of this plane H K L and Miller indices of this plane is H dash K dash L dash, right. So, this is the okay. So, this D H K L and D dash H K L. So, this basically for this distance for other plane where I could write H dash K dash L dash, but instead of that I have given d dash. So, this angle between these two planes, if it is theta, okay. So, you will get cos theta. So, if you take the cos theta is basically if you take the dot product of unit vector of this two O n and O n dash, if it is unit vector of this one is n, this normal direction is n, and for this normal direction is n dash. Okay. So, dot product of these two unit vector will give you the cos theta. So, that n basically unit vector for this. So, n I can write for this n I can write unit vector. So, that is basically DHKL vector and this magnitude of this one, right. So, that way we define the unit vector. Similarly, n dash it will be d dash HKL, this vector, magnitude of that one HKL dash, right. So, that n unit vector n and unit vector n dash, so the direction cosine is basically cos phi a, cos phi b, cos phi c, and for other one cos phi a dash, cos phi b dash, cos phi c dash. Okay. So, then from direction cosine itself one can write angle between these two as a cos phi a, cos phi a dash plus cos phi b, cos phi b dash plus cos phi c, cos phi c dash. Okay. And one can find out from here also, because you know the relation of DHKL and this cos phi or cos phi dash. Okay. So, using this one can find out this relation, or this also known that angle between two direction cosine is, if it is cos theta. So, in terms of direction cosine of each one, so this will be the relation with the angle between these two direction. So, from here if you just put this cos phi value, so cos phi value, right. So, this basically in this case h by this d, h by d by a, or b by d, k by d by b. Okay. So, if you put this value here, so cos theta will be, so cos phi a you will get d HKL DHKL H by A okay, and that phi dash you will get basically H dash by A, so A square, and DHKL dash right. So, these two will come in each term. So, if we take common, okay, and similarly other term k dash by b square plus L dash by c square, right, L dash by c square, so that you will get basically. Okay. Now, that DHKL that we have seen, what is the value? So, that if we put H dash by A square plus K dash by B square plus L dash by C square, right, divide by DHKL value. So, what was that? Just write that expression. So, that explicitly we write. So, DHKL value, what we have seen, I think this DHKL something wrong. No, cos phi H dash DHKL by A, right. So, DHKL value, so it will go up, it's going down H by A, right, H by A, DHKL value H by A whole square plus K by B whole square plus L by C whole square, right, and then to the power half into H dash by A whole square plus K dash by B whole square plus L dash by C whole square, right. So, now in crystal plane, so what is the planar spacing? What is the angle between these two planes? For that we have expression, so one can easily find out. So, if I ask you to find out the planar spacing for a plane, say 1 0 0 plane, okay. So, planar spacing HKL equal to 1 by H by A whole square plus a by b whole square plus L by c whole square to the power half, right. So, just putting value here, so immediately you can say that that will be that value will be a, right. So, these are 0. So, these are 1 by a whole square. So, square root of that 1 by a. So, it will go up. So, it is a, right. And 1 say 1 1 0, 1 1 0, what will the value? So, this will be 0, this 1 by a square plus 1 by b square, right. Now, in case of cubic crystal, a equal to b, right. So, here as I mentioned these relations are valid for the orthogonal system. So, where the axes are mutually perpendicular to each other. Okay. So, basically cubic system, tetragonal system, orthorhombic system, so these relations are valid. So, simplest one is cubic. So, in case of cubic, most of the example we will give in terms of cubic crystal, whether I mention or not, but it is mainly for cubic crystal. So, for this what will be the value? So, this basically 1 by a square plus 1 by b square. So, b will be a. Okay. So, it is basically 2 a square. So, square root is there. So, it will be 2 a square means 1 by root 2 a. So, it will be a by root 2, right. Similarly, for 1 1 1 plane, so it will be for 1 1 1 plane, it will be a by root 3. Planar spacing will be a by root 3. And if you find out the angle, say these two plane, angle between these two plane, the cos theta. So, you can see here only this term will exist, other will be 0, So, basically h dash by a square, right, and here basically you will get this for 1 0 0 you will get basically it will, if I write this way, it will be d value, right, dh scale d 1 0 0. So, that is basically a, and for this one other plane, this plane, so it will be a by root 2, right, and this 1 1, so this will be 1 by a square. So, this will be 1 by a square, right. So, 1 by a square, here a square, something wrong. Oh, okay. So, it will be basically this is basically 1 by d, this is basically 1 by d. So, you will get here 1 by a and here root 2 by a, right, root 2 by a. So, this will give you 1 by root 2 So, that is nothing but cos 45 degree, right. So, theta equal to 45 degree, right. So, it is if you draw 1 1 on plane, sorry, right. So, if you take this the origin, and that is a axis, sorry, a axis, this is b axis and this is c axis. Okay. So, your 1 0 0 plane, 1 0 0 plane is basically this plane, this plane, this plane. So, passing through the origin, so this will be the plane, this will be the plane passing through the origin, this will be the plane, and 1 1 0 plane, 1 1 0 plane, basically this plane, right, this and this. Okay. Okay. So, angle between these two is just from here you can see, just this is a phase diagram, right, and this is also angle between these two is obviously 45 degree. Okay. So, thank you. So, we will continue in next class.